Hey guys, this is Amit. Welcome to my class Python for Beginners. So guys, I hope you're enjoying the course up till now and you've been doing the homework and following the classes. Please keep sharing your feedback. I grow as I learn. I hope to make the course more engaging in the future with the constant feedback. I hope you improve. So guys, today's class we'll add another important tool to your programming skill. This skill is of using iteration in your programs. You remember that I showed you an example of how to print something 100 times in just 2 lines? Well, we'll master that trick today and in the next class. But first, let's take a detour and understand the updating of variables. So one of the most common forms of multiple assignment is an update, where the new value of a variable depends on the old. For example, you have variable x and you assign it the value x plus 1, which is written in Python as x equals to x plus 1. This means get the current value of x, add 1, and then update x with the new value. If you try to update a variable that doesn't exist, you get an error because Python evaluates the expression on the right side of the assignment before it assigns the resulting value to the name on the left. So if we say x equals to x plus 1, x plus 1 is evaluated first, but x is undeclared, undefined. It says x is undefined and that's why you get an error. But if you say x is 0 and now x is x plus 1 and then you print x, then you get a 1. So updating the variable by adding 1 is called increment, subtracting is called decrement. Now guys, let's come to the while statement. The computers are often used to automate repetitive tasks. Repeating identical or similar tasks without making errors is something that computers do well and people do poorly. Repeated execution of a set of statements is called iteration. Because iteration is so common, Python provides several language features to make it easier. The first feature we're going to look at is the while statement. So guys, let's open up a new file today and let's call it, this is lecture number 7, so we'll call our file 7.py. Okay guys, take a look at the function that I'm going to write just now. Def. The name of the function is countdown. That should ring a bell. Now, while n is greater than 0, print n equals to n minus 1. This is the update. This is the print. Finally, when you're done, blast off. Now it's gone down to 10. Let's see what happens. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. You can almost read the while statement as if it were English. It means while n is greater than 0, continue displaying the value of n, then reducing the value of n by 1. When you get to 0, display the word blast off. More formally, here is the flow of execution for a while statement. Evaluate the condition. Okay, so for the condition you actually need to know what the structure of a while loop is like. So here it is, while condition, and you have a block of statements. I'll put this in as comment. Okay. So evaluate the condition yielding false or true. If the condition is false, exit the while statement and continue execution at the next statement. If the condition is true, evaluate each of the statements in the body and go back to the previous step. So it evaluates the condition n greater than 0. It starts with the value 10, evaluates 10 is greater than 0, it's true. It prints 10, n is decremented, n becomes 9 now. So let's have a trace of this program. So what it does is, you say the value 10, it says, okay, the value that is input is 10 initially. Now 10 is greater than 0, 10 is printed. So let's say current value and what is printed. Alright, so current value of n is 10. Now what is printed is n is now decremented, so it goes back to the while loop again, to the check again. Now n is 9, current value is 9, 9 is greater than 0, print 9. Sorry about this, guys, this is going to be irritate us. Okay, now n is decremented, n becomes 8 now. Okay, let me do it this time, darkening the line so that it makes it easy to follow. Let's do it for a smaller value. Let's say I want to count down to the number 4. Okay, so you call countdown on the number 4 while. Now you encounter a while block. So n is 4, 4 is greater than 0. It enters the while block, print n, n is 4, 4 is printed, n is decremented, n becomes 3 now. It's here. It goes back to this line. Now n is greater than 0, n 3, 3 is greater than 0. It enters, prints 3, n is decremented, n becomes 2. Goes back to this line, 2 is greater than 0, 2 is printed, n becomes 1, again back, 1 is greater than 0, 1 is printed, n becomes 0 now, goes back again, 0 greater than 0, this is false. Don't execute these two statements now, execute this statement, blast off. This is exactly what happens. You can check it again, 4, 3, 2, 1 and blast off. So if you made this change n greater than equal to 0, 0 will also get printed. If you say n greater than equal to minus 1, now minus 1 will also get printed. So that way. So this type of flow is called a loop because the third step loops back around to the top. Notice that if the condition is false the first time through the loop, the statements inside the loop are never executed. So when n was greater than 0 was the condition to be checked, and n became minus 1. So when n became 0, it goes back to the first line of the loop, which is the check on the loop. 0 is checked, that if 0 is greater than 0, which is false, so the statements inside of the loop are never executed. So the body of the loop should change the value of one or more variables so that eventually the condition becomes false, because you don't want the loop to keep on printing numbers, right? You don't want the countdown to keep happening. You have to stop the countdown somewhere. So from 10 you count it down to 0 and now you have to stop. You just can't keep on counting down forever. That's why you need to decrement the variable n, otherwise this loop will go on forever. Such loops, which repeat forever, are called infinite loops. An endless source of amusement for the computer scientists is the observation that directions on shampoo, lather, rinse, repeat are an infinite loop. Okay, so we have now created the program, and okay. So in the case of countdown, the function we have written, we can prove that the loop terminates because we know that the value of n is finite, that the value of n which we enter, 10 or 4, is a finite value, and we can see the value of n gets smaller each time through the loop. So eventually we have to get to 0. In other cases, it's not as easy to tell whether the loop is going to end or not. I'll give you an example of a function, and let's see if you can figure out why it's hard to tell if it will ever stop terminating or not. So let's say we have defined a sequence n. So while n is not equal to 1, so you keep on executing the statements below in a loop till the time you encounter n equals to 1. You print n. Then if n is divisible by 2, change the value of n to n by 2, otherwise update n as 3 times n plus 1. Now you call the value of sequence on 15, and let's see what gets printed. Number 15, 46, 23, 70, 35, 106, and so on. Why does this happen? So let's say we want to trace this on the value 2. Okay, so 2 is not equal to 1, it prints 2. Now n divide mod 2, n is 2, 2 mod 2 is 0, n becomes n by 2, so n becomes 1. It goes back again to this statement, n is 1, it stops terminating. Let's say we have the value 5. Now what happens? Okay, so n is not equal to 1 because n is 5, print 5, 5 mod 2, 5 is not divisible by 2, go to the else block, n is equal to 3 times n plus 1. So n is now 3 times 5 plus 1, which is 16. Go back again, 16 is not equal to 1, print 16. 16 is divisible by 2, so n now becomes 16 over 2, that is 8. Go back again, 8 is not 1, print 8. 8 is divisible by 2, n becomes now 8 by 2, 4. Now go back again, 4 is not equal to 1, print 4, 4 is divisible by 2, n now becomes 4 by 2, that is 2. Go back again, 2 is not equal to 1, print 2, 2 is divisible by 2, n now becomes 2 by 2, that's 1. Go back again, n is now 1, 1 is not equal to 1 is false, because 1 is equal to 1 is equal to 1. So do not execute these statements, exit out of the while block. There's nothing after the while block, so the sequence, the function sequence terminates now. Okay, let's move on to a new program which counts the number of digits in a number. So how do we go about writing that program? Okay, this program is called numDigits on n. We're going to keep a counter for the number of digits, initialize it with 0. Now what do? You say while n count is equal to count plus 1 and n is equal to n divided by 10. We just return count. So we call print numDigits See what happens. It says 3. Trace the program and convince yourself that it actually works. How? You enter the number 235. Count is 0. So while n is, so I told you that a Boolean expression, Python will assign an integer type to a Boolean type. So when n is anything but 0, this expression while n will evaluate to true. So this expression n, the condition in the while condition. So you can say while n is not equal to 0, or you can say while n, because when n becomes 0, while n will also evaluate to a false, otherwise it is true. So you say while n, so n is 235, say count plus 1. Now n is n over 10. 235 divided by 10 is 23, so n is now 23. Again it goes back to this line, while n is 23, while n evaluates to true, it goes inside, count plus 1, so count becomes 2 now, and n now becomes 23 over 10, that is 2. Go back to the first line again, while n is 2, which is true, count plus 1, count becomes 3, and n equals to n over 10, n was 2, n now becomes 0. Go back again, while n is now 0, this evaluates to a false, exit out of the while block. The next statement out of the while block is the return statement. Return the current count is 3, 3 is returned, and the num digits function exists, and you get the value 3. Now let's say you wanted to count the digits that are either 0 or 5. That means for any input number you want to count the number of digits which are either 5 or 0. So what can we do here? Well, let's copy this program. Okay, number of digits, let's call this number of 5 and 0s. Okay, so count is 0, while n, you say n. Now you do not directly increment count, while n. Now I told you how to extract the last digit of a number. How you do that is you take the modulo of the number by 10. See, say a digit is equal to n modulo 10. So digit will now have the last number, the last digit. So if the input was 235, digit now has 5. Now if digit is either equal to 0 or digit is equal to 5, then you say count is 1 plus 1. And regardless of that, you want to decrement n. So let's trace it on our program. 1053. Okay. First, let's see if it works. It says 0, which is true. Let's see how it works. So a good thing to observe what happens here is to add print statements in between. So let's say you want to add print digit here, and each time after you have updated n, you want to print n again, just to know how the program flow works. Okay. And actually it's much better. Sorry, if you print digit and this way, Okay, so now you have 1053 as the input. While n, count is 0, while n is 1053, digit is n modulo 10. Now you printed the digit here. Digit is 1053 modulo 10, which is 3. It matches with this 3 here. Digit is either a 0 or a 5. No. Update the value of n, make n the original value by 10. 1053 by 10 is 105. Now print digit and n. So digit is 3, n is 105. This is what you get. Now go back again. While n is 105. So digit is n modulo 10. 105 modulo 10 is 5. Digit is 5. This is true. Increment count. Now update n as n by 10. 105 over 10 is 10. Print digit and n. Digit was 5, n was 10. This is what you get. Go back again. N is 10. Digit is now 10 modulo 10, which is 0. Digit is 0. Count is count plus 1. Count now becomes 2. N is n over 10. N becomes now 10 divided by 10, which is 1. So print digit n is 0, 1. Okay, now while n is 1, digit is 1 modulo 10, which is 1. It's neither 0 nor 5. Count does not get incremented. N gets divided by 10. New value of n is 1 over 10, which is 0. Print digit comma n. Digit was 1, n was 0. 1 0 gets printed. N is now 0. While any value is false. This whole block is not executed. Now next statement, after the while block is the return. Count is 2. 2 is return. So print gets the return value of 2 from this function. So the argument of the print is 2. The 2 gets printed on your screen. Alright. Now this is another one. Let's say you wanted to print the powers of 2. So let's do something like that. We can say, okay, x is equal to 1. So let's say you want to print the first 10 powers of 2. So while s is less than equal to 10, print x, comma, this is the tab character. So you want to print x, give a tab space, and then print 2 raised to the power x. And x is x plus 1. Because if you didn't increment x, while x is less than 10 will always be true because x is 1. So let's see what happens there. It prints the powers of 2. It's easy to trace this program. Trace it yourself. If you find any difficulties, please feel free to email me or share this on the course page. That's it for today, guys. We learned about the for loops and many more things in our next class. See you around. Do take care and do your homework. Bye, guys.